This team of ours, led by Steve, who's sadly sick at the moment, but will recover for next week, we aim to improve the industry confidence in choosing appropriate methods for managing water repellent soils for cropping in the state. We collaborate with numerous agribusinesses and growers and grower groups in the state, as well as a team from CSIRO. So this is very much a highlights presentation. Much more detail you'll find in the paper itself. So some of you would have been familiar by now with these dramatic effects which Steve and others and Peter Newman have shown you over the past couple of years of how some methods can really change the productivity of some of these soils which suffer from water repellents. And this was at Marchagee in a reasonable growing season, and its comparison is with a knife point sow. Knife points were used in both parts of the area, but obviously there's a huge difference there. Now, more recently, we've found dramatic effects like this in this loping crop in this paddock. And again, knife points have been disappointing. But would you like to offer me, any of you, the name of the treatment on the right, which has produced this much improved, dramatic improvement? Do I hear spading over there? No, I'm sorry, it's not spading. No. Mobile ploughing? No, I'm sorry to wetting agent? No, I'm sorry to disappoint you. No. Well, all that happened is that another bar came in and sowed with a boot with wings on. The small wings on the boot. That's the only change in this paddock. Now that's the more dramatic effects of this. Other times it's not quite as dramatic, but we are finding cases where the reason those control plots are so poor for knife points, the reason they look like the old level sown controls we did in the 90s, even though they've got furrows, is that furrow sowing can fail, especially when the knife point is involved. Anyway, I'll come back to that, but what we have at the moment, and many of you will be aware of, is that for this battle against water repellents to improve cropping, we have a number of weapons in the arsenal. And they include the things we know a lot about, such as claying or delving, soil inversion, which we've learned of recently, and rotary spading. The banded wetting agents we've known for a number of years, and blanket applied agents too. And we've recently come to understand these better with CSIRO's investigations and on-row seeding, and this improved furrow sowing. And there are some other methods developing, but these are the most principal ones which are involved at the moment. So what's gone wrong with furrow sowing on water repellent soils? This is a case at Badgingarra last year where knife points produced this kind of effect on a water repellent gravel. And what seems to be happening, and this is, you have to imagine this is a cedar bar coming towards you. Don't worry, you're perfectly safe. No one will die in this demonstration. And at the front of the knife point, because they're particularly vertically, their rake angle is particularly vertical, there tends to be a bursting up of very light water repellent material, a lot of it organic matter, which then moves like water and flows around the point and gets incorporated into the seed slot and around the closer plate and eventually ends up with the seed and the fertiliser. So what happens is we've still made a furrow, and rain can come onto this dry ridge and still be water harvested in the bottom of the furrow, create a small depth of water with a pressure head, and do the same thing as it's ever done, as push water into that soil beneath it, but it tends to meet like a sausage of rather repellent soil and travel around it and leave much of the seed and the fertiliser dry, which is rather the opposite of the intention of the furrow sowing. So what seems to happen when there's a small wing there is that the wing appears to lift, not necessarily throw, but at least lift, and the soil to each side of that knife, if you like, has now got a greater slope, and this fine, light, dry material, which moves rather like water, does what water does when there's a slope, and tends to move further away from the point, and further away from the sowing zone, and tends not to get incorporated into the seed slot. Now that's the general picture. Now whether the wing's on the point or on the boot There seems to be similar. And that's terribly simplified, and we're still studying it. But that's the basic idea which I hope you've got in your head, which explains why these wings seem to make a difference. Okay, and here's an example of where we did stuck a wing on an existing knife point and went ahead and used it. But when Steve was looking at a commercial bar with wings on the sowing equipment against knife points, these are the key water content measurements he found. Here with the improved furrow sowing, we're getting what we want. We're getting a high water content with the wing point, the improved furrow sowing, in the furrow where the seed is, the lower water content, which is particularly dry, in the ridge. But with the knife point, we're getting reverse. With the knife point, we're getting the dry conditions in the furrow where we don't want it, and the moistures in the ridge. So this was a commercial bar against a farm knife point bar running at Badgingarra, and here are the two circumstances, the knife points and the improved furrow sowing, which includes knife points and other things. And here's a close-up. This setup includes paired rows, so that may make a difference. We're not sure of that. It includes a higher press wheel pressure. That may make a difference too. And good seed and fertiliser separation, but we don't think in this case that was a major issue. And here was the effect on establishment, either on the sand or the sandy gravel in this paddock. We got very noticeable improvements in wheat establishment, and that led through, even in a very generous season last year, it led through to yield improvements at the end of the year. So let's leave that for the moment, and let's look at the bounding wetting agent story, which has been around for a long time, but it's probably the trickiest one to set up and use well. And here I'm really talking about it as for dry sowing, even if there's just a layer of dry soil over moist subsoil. We're really trying to use it mainly for a dry sowing situation. There are some key design guidelines we're putting out in the Ag Memo and Ag Tactics as soon as we can. But the key to that is really the press wheel design. One downside of this kind of press wheel, which is rather rectangular with bulges at the side, is that when it rolls backwards, it rips up the edge of the furrow or the trench, and you get these two rooster tails of material, which also break up the material, the soil, and when the spray is trying to hit stationary soil, it actually gets sprayed into a whole tumbling mass of soil from the ripped up edges, and it is mixed into that layer. It's not really in its ideal position. So that's one of the reasons some of the setups haven't been working as well as they could do for establishment. Now, when we have used even this poorer design wheel, last year in lupin sowing into dry top soil, but there'd been summer rain, so there was moisture in the rows and moisture in the subsoil, we found that between the rows, without the banding, we're only getting a very low population of lupins. When we had the banding wetting agent of various products, we got a higher population, but I think it would have been further up here had the press wheel been a better design, because the previous seasons on that farm were doing that. However, when we went into the old row, where there was moisture from the summer rain, we got a lot of benefits, particularly even when we weren't using the surfactant. So there are two kind of stories here. One, how the banding surfactant can work, and we've known that for a long time in dry sowing situations, but the press wheel design should make this better. But more importantly, and some of it coming out of Margaret Roper's work, when we can actually be in that zone which has accumulated water and kept it there, and the old row, there's a benefit we can use. And here's an example from some of Margaret and Phil's work where you can see those better rows and the poorer rows that were sown in the interrow. So there's a tool, there's a weapon in the armoury. Let's look at these long-lasting weapons in the armoury which can do a lot of good in small areas and are relatively expensive. You know about rotary spading, you know about multiple ploughing now, and you've known for a long time about claying of various kinds. For the rotary ploughing and the spading, which are relatively new compared to claying, here's some of the longer term effects we're seeing. Although the numbers are small in the older times, some of these sites which Peter Newman has helped establish, we are seeing that in many individual sites the yield is holding up with time with multiple ploughing. And of course very old herbicide-resistant weeds is a key part of that thing, which spading can't do. In the spading there isn't quite the same age, but we have in some sites a tendency to decline in response with time. This particular large negative number is a word of warning. The spading was done on a sand near Una where there was a high aluminium toxicity in the subsoil. The roots couldn't really explore it. And so this crop, which grew well, crashed and ended up with 15% screenings. So there's an example of where it isn't used wisely in a good profile, you could be in trouble. Anyway, there's some evidence there that the rotary spading may not be lasting as well as it has the ploughing. But don't forget the rotary spading, it's very good at incorporating clay and nutrients and lime. And here's some work Craig and Brianna was doing at Badgingarra to look at more detail. They were doing a time team study, and on the way down they looked at the size of the holes and examined where the roots were growing in either the untreated treatments or in the mulbore plough treatments, the spading and a surfactant treatment. And one key part of this whole story seems to be that this buried topsoil attracts a lot of root growth. So in the subsequent years, Steve's found up to 5% more available water in these zones. And that could be one of the big drivers, that these more active growth of roots and their subsequently dying of this root mass may be accumulating and improving the retention of water in these zones and helping the subsequent growth of the crop. But there's still a lot we need to learn about this method. Here's detail on the measurements of root interception on these faces that Craig and Brianna have done. And the most noticeable effect here is, look, in the top 30 centimetres, that's 30 centimetres depth, there's really abundant development of roots in the spading and the mulboarding. And we know from experience that in claying you can do similar things in certain layers too. The improvement of the soil, the mineralisation, the general improvement, encouraging a lot more root growth. Sometimes there seems to be more in the control of depth, but with the control it's more shallow. Wetting agents made a small effect, but not as much as this. But the downside of this major cultivation practice, especially on the south coast, where it's particularly windy and the sands are fine, is the wind erosion risk. We know that from experience. We've known that a long time. Now here you can see a case where the response was still very good, even though the start was very windy. And some people may argue they can live with that, but I think we should ask the question, can we do this in the winter more effectively sometimes and still fit it into a system very effectively? And can we reduce the erosion risk before sowing? This is a site I'm managing at Ballard, north of Geraldton, where we had mulbore ploughing in the background, we had rotary spading, and the claying was incorporated shallow using a spader, but the spader couldn't use the rear covering roller, so it wasn't smooth. This user travelled across it to get samples before the wind came. Here in the pitted ground, where we'd incorporated the clay, even at very low rates on the edges, only about 20 tonnes a hectare maybe, these divots seem to have slowed the wind down and reduced the fill of these wheel ruts. Where it was smoother, these wheel ruts are half full. Over on the mulbore ploughing, where you've got much more of the subsoil exposed, these wheel ruts were completely full. So is there an argument that some kind of pitting of the surface after these cultivation methods may help? Lots of questions. The claying, in general, we've got people using higher rates and using modest rates and different degrees of incorporation. And if we look at the data over the drier seasons in the north, there is a trend that in the drier seasons we're getting poorer responses. The 21st century and 20th century are explained here in this slide, but we'd still like to know more about it. But this particular site at Ballard did nothing with the clay this year.
That's 15 minutes.
And here we have the clay showing up as a greener colour for nutrition at Badgingarra last year, and most of the response is being in just the presence of the clay. And look, this is a control only incorporated by the seeding operation and the deep ripped only by the deep ripping and seeding. Shallow incorporation may be having a good effect and quite economically. We want to look at that more closely. Anyway, let's look at the draft strategy. We could have this progressive amelioration of some of the paddocks. Perhaps inversion ploughing is enough for the more herbicide resistance. We have to be careful with the depth. Claying at the effective rate and the appropriate method. Maybe modified deep ripping will work. And spading, and that's according to the rates of investment. And the mitigation methods would be the improved furrow sowing, the banded wetting agent, and the sowing to depth, and the blanket products. Where the stubble retention fits in, I don't know.
Hi, Paul, it's Dave. Could you give us a breakdown on the costs, particularly in the mitigation side? Just to have a look at, maybe do a comparison between the progressive amelioration and the mitigation side for us. Just give us an idea of the costs.
Yes, Dave, of course. I haven't really tried the economics in great detail yet, but in general, this method seems to be around $70 a hectare. This method can be various costs, 200, 300, depending on the rates and where the source is from, how you're incorporating it. The spading, someone might have to remind me what the cost of spading is, but it's in this order. Whereas for the improved furrow sowing, it looks like a change of points or boots. For this, it looks like a change of press wheels and a bit of care on the system. Sowing to the old row looks like having to maybe go to 2 centimetre guidance and set it up in one year and go in the next, and you have to have a summer rain beforehand or the previous rain to make the previous rows moist. The blanket products, the cost of this runs at about, with 1 or 2 litres a hectare, between $10 and $20 a hectare. This might be 20, 40, 60 litres a hectare with similar price products, but it's going to be localised, and you might be not to consider the total cost, and it's very specific to some soils. And this system, not really sure about that at the moment, but it is a change of methodology for some to retain as many of the old roots in the system as possible as pathways for future wetting. So the costs in general are low on this side and higher on this side. And it's generally slower here and quicker here. If that's any help.
Thanks, that was an interesting presentation. Can you give us a little bit more detail about showed that photo of a winged point that had been obviously just modified. Can you give any more details on the types of points that you've tried? And
it goes back to the earlier furrow sowing days in the 90s when we never used knife points as a standard treatment. They were always wing points. Even the superseder point, you might remember, was a no-till one. And then I did some work on delving moist sand below dry sand, which the Williamson family had developed in unit. And they were using a superseder running at 8 inches. And we compared that with different designs. The guts of that effect was a wing to enable some lift. And so the same features we saw in that study seemed to remind me of why the knife point just wasn't cutting the mustard, as it were. This is the one you meant, isn't it? But simply a small wing.
Use your laser, Paul.
Yes, sorry. A small wing fitted onto this knife point with advice from some point design companies, and our little notch at the back in case we wanted the fertiliser to travel there, but it wasn't important, I don't think. It has to be rather behind rather than in front, so it's trying to lift the soil at the sides. The other feature is that when the rake angle is more shallow, then this bursting effect is less. There is some research showing that will reduce the amount of material that gets into the seed slot. So in general, designs which have got a more of a slope on and a little wing, which is very close to the old superseder. And sometimes closing systems which are actually closer behind the point and don't have the same depth control mechanisms to this, because when they're trailed, the return path of this material is more likely to get into where the seed's been incorporated, whereas if the seed's going here, for example, then the return path tends to be behind it. But this is the other part of it, the press wheel, because that's not the press wheel designed for this unit. That's the press wheel designed for this unit. This is another press wheel with a more of a sloping side. But that's the guts of the idea, is a wing. But what's happened with some of the other designs is the wing on the boot seems to have achieved the same effect. So perhaps it's also with a knife point, it travels here and then round here and gets in here, the fine water repellent material. But even if you've got a wing at this position, you might achieve the same lift, which encourages the flow to be further away from the seeding zone. So it does at the moment look, on first rough glance, it's either a winged boot system, without naming any producers, or a winged knife point type system, or a point with a wing, which is going to minimise this incorporation of fine water repellent soil into the slot, combined possibly with a reduction of the slope angle, so it slopes back more.
Won't worry on that photo, Paul. You mentioned that's not a particularly good design press wheel because it rooster tails the dry material and mixes it in with the wetting agent.
This one?
Oh, yeah. That one. So the one close is a better design that's got the wedge on it?
It has more of a slope, so when it rolls back, there aren't these bulges to rip up the sides of the trench it's working in, if you like. So if your press wheel is a round cross-section, or if it's V, perhaps with a flat bottom, but it's the sides of it which seems to be critical, not vertical sides, or this press wheel doesn't have vertical sides, it has bulge sides. And the other press wheel it will happen on is if it's a shallow press wheel with a deep rim, the sand will flow into the rim and be thrown up behind it as it rolls forward. So a solid face on the press wheel, but not bulge sides, but like tapered sides or rounded sides.
Tony Fisher, my question, Paul, is that distribution of roots that you showed, there seem to be a lot less roots at depth.
Yes, this was one of my concerns and one of the possible downsides of improving the topsoil so much. And it shows up in the clay work, particularly in our drier conditions further north and maybe more inland from the south coast, because much of the development of clay was on the south coast successfully. So, as you're seeing, a concentration and a higher activity, and I suppose if it's got the same amount of energy and carbon to invest in the system, then it tends to invest less down here, as it seems to have more down here than here. And the consequence of that, in a hard finish maybe, this grows more biomass, extracts the water from this lane more easily, can't get down into these things very rapidly once the root system's finally grown at anthesis, and so it runs out of water at grain fill. And that extreme case we had at Una, where the root development below the, this is spading, not moldboarding, root development below the spading was restricted by aluminium toxicity, and that crop hayed off and went to 15% screening, so it was a very poor yield. So the consequences of this extra activity in the wrong kind of season and circumstances, whether it's from the cultivation or by claying, may have some negative effects.
Could it be that the water's not going deep where you don't have the preferred flow from?
I think if it was a structured clay, Tony, as I remember working on in the good old days, then we may have closed off some macropores with this kind of activity and therefore flow through macropores, but these are sands, these are biologed sands, so they're naturally fairly permeable to water and air. And so these effects of cultivation don't have the same influence on water and airflow as they do on structured clays or clay loams.